Well, good day, everyone. Here we are for our second unit for our ProbStat discrete class, and we are going to start to talk about counting. And the first idea we need to go over is the fundamental counting principle. And so I'm just going to say what it is here. It's written down for you so you can take notes on it. You can pause and do that if you like. But here's what it says. If one can choose one item from a group of m items and one item from a group of n items, then the total number of two item choices is m times n. So think about that for a minute, and here's an example that I'd like to explain to you. So suppose we have Javier, and Javier is a clothes hound, which means that Javier likes to wear lots of nice clothes when he's on dates or going out. You like this, Javier? I hope you like this. Anyway, so whenever Javier goes to his closet, he always needs to choose a pair of, we'll call them pants, some pair of pants. He needs to choose some kind of shirt. He needs to choose some kind of shoes, and he needs to choose a belt. And then Javier will be a well-dressed young man. So I'm going to flip the screen here, and we're going to take off with this example, and I'll show you how the fundamental counting principle applies to that. So now we're at Javier's closet, and we see not only does he want to wear pants, shirts, shoes, and belts, but that Javier has 5 pairs of pants, 10 different types of shirts, 5 pairs of shoes, and 3 different belts. And the question is, how many outfits can Javier make? So what do you think? How would you do that problem? How many outfits would Javier make? Now I should mention that it doesn't matter if Javier's outfits match. He could be well dressed and quite unmatched. But in general, we're just trying to find how many outfits. And this is the basic question of the fundamental counting principle. So here's how you would do it. Javier goes to his closet, and he knows that he can choose one of 5 pairs of pants. He can choose one of 10 shirts, one of the 5 pairs of shoes, and one of the 3 belts. Well, if you go back to the definition, it says that if you choose one item from a group of m and one item from a group of n, then the total number of 2 item choices is m times n. Well, if we were just dealing with shirts and pants, that would be the number of 2 item choices. Then Javier would have m, or 5, times 10 n shirts, or 50 possibilities. But then if he wants to choose shoes and belts, so in his shoes and belts, he wants to know how many different combinations of shoes and belts he has. He has 5 times 3, which is equal to 15. So how many combinations of pants and shirts and shoes and belts? Well, he has 50 combinations of pants and shirts and 15 combinations of shoes and belts. So by the fundamental counting principle, he has 50 times 15, which is equal to 750 different outfits. Is that what you got for your solution? So what I have listed here are a few categories of where you can have questions that use the fundamental counting principle. For instance, you could talk about license plates. When we look at license plates in Nevada, I believe they have 3 letters and is it 3 numbers? So we have 3 letters and 3 numbers, but each letter has a choice of 26 letters in each case. And each number, you have 10 choices in each case. So by the fundamental counting principle, what would you end up for the number of possible license plates? Well, what you would do is you would then multiply 26 times 26 times 26 times 10 times 10 times 10. And that's quite a large number for how many possible license plates you have. I have also seen this done with sandwich types at a store. If you go to Subway, for instance, at Subway, they have, what do they got? Wheat bread, white bread, sourdough, Parmesan, honey oat, and flatbread. I think they have 6 types of bread. Well, how many types of meat do they have? Well, they have turkey, they have ham, they have beef, they have cold cuts, they have meatballs. And so you can start to see that as you go through this list, pause, my phone's ringing. So that was my lovely wife calling and just interrupting my video, but no big deal. Let's go back to sandwich types. As we mentioned bread and meats, and now you could do cheeses, and then you could do the toppings, and then you could do the condiments, like they do the salt and pepper, the vinegar and oil, mayonnaise and mustard. And you could see that there are really quite a large number of types of sandwiches you could actually make at Subway with all their variations. Another good example is like a course schedule. For those of you, when you get ready to go to college, you're going to find out that there might be 3 or 4 English classes that you'd want to take at different times of the day, some math classes, science, etc. And in order to make your schedule, it tells you can figure out how many possible schedules you could have, and then you're going to essentially settle on one of those that you feel is best for you or that you can just get. And so example 3 in your textbook on page 610 is a good example of that. Example 5 in the textbook does multiple choice tests, and every multiple choice test is how many possible answer selections can you do? Well, if you had a 10 question test and each question had 4 choices, you know, how many possible arrangements of the test could you get in terms of those 4 choices? Well, each question, there's one question, then 4 choices, so you'd have 40. And so that's the typical stuff. You can do telephone numbers. I see here there's shopping, new car choices for amenities, a pizza. You know, you got different kinds of crust, different sizes, and different toppings. So there are quite a variation of things that you can do to come up with these types of problems. And the trick is, just as in the license plate problem though, is you have to decide, what do I have going on here? Oh, I have 3 letters. There are 26 choices for each letter. Or, oh, I'm doing numbers. I have 10 choices for each number. So let me vary the license plate a little bit. Suppose I have a license plate, and in the state that I live, suppose they say the first letter cannot be an A. So no A's in the first slot. And they also say that you can't use a 0, so no zeros, no A's in the first slots. Now, how would that change how many license plates I could make? Maybe their state vehicles use A's and zeros or something like that. That would be a reason why. Well, how would I do that? Well, in this case, there would only be 25 choices for the first letter, then 26 for the next 2 letters. In this case, there'd be 9 choices for the first number and then 10 choices for the next number. And now you can start to play with this idea. Well, what if I use a letter once and I'm not allowed to use it a second time? Well, then the numbers would tend to go down by one. Or what if you must have a sequence where at least two letters or two numbers are exactly the same? So there are all kinds of variations that you can do, and that's what I want to mention. Our homework for this is going to be, we're going to focus on page 612 to 613, and we're going to look at all the problems 1 through 28, and when you get to class I'll assign you a certain number of those, but you can start looking at them so you have an idea of what you're going to have to do. Okay, talk to you later. Bye.